In this unit, we'll be looking at sequences and series. Now, a sequence is essentially just a pattern of numbers. So right here, 6, 13, 20, 27 is a sequence. We'll first be looking at what are called arithmetic sequences. Now, an arithmetic sequence has a common difference, which we use a variable d for, between consecutive terms, starting with the first term, which we use the variable a for. So for this first sequence, a would be the value of 6. Now there's some sort of common difference, some sort of pattern on how we go to the next number, to the next number, to the next number. And we use the variable d for that. For some of these sequences, you can figure it out just by looking at it. But one way to figure it out, if I take a look at the second number, 13, I can subtract the first number, or the number before it, 6, and that gives me a common difference of 7. So what you can notice is we add 7, add 7, add 7 as we go through the sequence, and that will just keep continuing on. For the next sequence, again, we have an a value 12. That's the beginning of the sequence. And it may not be so clear what the pattern is here. So what we can do is, now you don't have to choose the first and the second term like you did last time. It can be any two consecutive terms. So what I can do to figure out my d value, I can take negative 58 and subtract the term before it, negative 23. So what we'll get is d is negative 35. So negative 35 is being added to each value to move down the pattern. Okay, so that's what an arithmetic sequence is. It's adding that common difference. Now, we'll develop a general formula that we can use. Now, the notation we're going to use is a lowercase t, and then n is going to represent the number, or the position number within the sequence. So, for example, t3 is going to represent the third term in the sequence. Now, for all of these sequences, arithmetic sequences, we start with the value of a. And then, for example, we are going to add d once, or we're going to add d twice, so plus 2d, or so on and so on. Now, the question is, how many times do we add that value of d? Well, if you think about it, term 1 is equal to a. We don't have to add d to get term number 1. Now, term number 2, the second term, will be equal to a plus d. Term number 3 would be equal to a plus 2d, because we'd have to add d twice to get to the third term. Term number 4 would be a plus 3d. Now, at this point, you're probably seeing a relationship between the term number and the number of times we add d. The number of times we add d is 1 less. So a plus n minus 1 times d. This will be our general formula for figuring out an arithmetic sequence, or figuring out one term in an arithmetic sequence. So we'll take a look at a few examples here. So given this sequence, 2, 6, 10, dot, dot, dot. So the sequence goes on. We want to figure out what the 15th term would be. So what I want to figure out here, or what I'm going to list, I'm first going to list that, okay, the a value is 2. That's my first term. The d value, the common difference, now I can figure this one out just by looking at it. I'm adding 4 each time. And it looks like my n value, I want to figure out the 15th term. So n is going to be equal to 15. So now I can write out my formula. So for the 15th term, I use the notation t15 equals, we have 2 plus, now in this case, n minus 1 would be 15 minus 1. I prefer if you don't just write 14. I'd like you to show me 15 minus 1. But on your calculators, you can just type out 14. And that will be multiplied by d, because we're adding the number 4 14 times. So this will give us that the 15th term is equal to 58. So instead of just adding 4, adding 4, adding 4 over and over, we can use that formula to just figure out that the 15th term would be 58. Now, other sorts of questions that we may find. So given this sequence, negative 3, 0, 3, and then dot, dot, dot. Now that means that the sequence is continuing, but then we have 81. That means we are finishing at 81. How many terms are in this sequence? Now we know that the first term, a, is negative 3. I can figure this out by looking at it, that the common difference is 3. We're adding 3 each time. Now, here's the thing. If negative 3 is term 1, 0 is term 2, 3 is term 3. I don't know how many terms are in the middle, so I don't know the term number for 81. So I don't know what n is, but what I do know is that term is equal to 81. So we're still going to use the same formula, the same equation, but we're just going to be using it in a different way. So 81 is equal to, so normally we'd figure that out, but we know here that it's 81. So negative 3 plus n minus 1 times d, which is 3. Now I can just solve for my n value here. So I'm going to add that negative 3 over to the other side. So we get 84 equals, and I'm going to expand this right here. So that'll be 3n minus 3. So still going on to solve, adding that 3 to the other side. So I'll have 87 equals 3n, divide by 3. And we get an answer that n is equal to 29. So the 29th term in that pattern would be 81. So again, it's still the same formula, but now we're solving for one of the different variables. So here's another type of question. Now, the 32nd term of an arithmetic sequence with a common difference of negative 4 is negative 113. What is the first term? So we know that, well, we know that we have to find out the first term. I don't know what a is, but what do I know? Well, this question doesn't give me any part of the sequence, but it does say specifically that the d value, common difference, is negative 4. I also know that the 32nd term is 100 or negative 113. So t32 is equal to negative 113. So remember that this 32, that's actually our n value. So again, I'm going to use the formula. I'm going to put everything where it needs to go. But this time, we're going to be figuring out what a is. So a plus n minus 1. Now, n is 32 minus 1 times d is negative 4. And again, this is an equation I can solve. So 31 times negative 4, I'll have a minus 124 is equal to negative 113. So now adding that 124 to the other side, I can solve that a is equal to 11. So that means that the first term in this sequence is 11, and by subtracting 4, subtracting 4, subtracting 4, by the time we get down to the 32nd term, we're all the way at negative 113. So just going back up for a moment, just remembering what this general formula is, as long as you understand where everything goes, you can solve for any one of those variables. Now, the last sort of question that we're going to be doing here, this will get a little bit tricky, and you're going to have to remember a concept that you learned back in grade 10. Now, we'll see what that is in a moment. In an arithmetic sequence whose third term is 23 and 40th term is 319, we have to figure out the first term and the common difference. Well, let's write down what we know so far. We know that the third term is 23 and the 40th term is 319. Well, I'm going to start with the 40th term. There's a reason why, and we'll see a little bit later. So I know that the 40th term, T40, is equal to 319. I also know that the third term is 23, so T3 is equal to 23. Now, this is not so helpful for us right now. We can't figure out what A is or what D is, the first term and the common difference. So here's what I'm going to do. I'm going to write out term 40, what that general formula would look like. So it would be 319 equals A plus, now we'll save ourselves a little bit of trouble here, n minus 1 would be 39 times D. So that's what the general formula for term 40 would look like. Now for term 3, I'll do the same thing. So 23 equals A plus, now n minus 1 would be 2D. Now, if you look at this, how I wrote the equations and how they're stacked over top of each other, you may remember how to solve by using elimination. Now, because we have A and A, they can eliminate each other by using subtraction. So I'll subtract these two equations and we'll see what we're left off with. So 319 subtract 23 will leave us with 296 equals. A subtract A, it's gone. It's no longer there. And now all we have is 39D subtract 2D will leave us with 37D. Now I have an equation with only one variable. I can divide both sides here by 37. And I get a common difference of 8. So that's the first thing that the equation, actually that's the second thing that the question was asking us for, the common difference. But we were able to solve that by writing out our two general formulas and then by solving by elimination. Now to figure out the common difference, all we have to do is take that common difference and substitute it into one of the two equations. Now, it doesn't matter which one you choose. I'll typically go with the one that looks easier, so I think the second one looks easier. So I'm going to sub D equals 8 into term number 3. And that's going to allow me to solve for A. So I'd like you to tell me which one you're substituting into, just for proper form. So 23 equals A plus 2 times 8. And just very quickly, that would give us 16. And subtracting that, we get an A value of 7. So just again, by using that general formula, we can come up with two equations, solve by elimination, which is something that we did last year, and we can solve for the common difference and the first term. So this is about what we need to know about arithmetic sequences. Number one thing is to understand that formula, be able to place everything in the right place, and then you can go from there and solve.